Hello and welcome dear students. I am back again. I am Sameer Chincholikar and I will be discussing today some interesting problems of permutation and combination. This is one of the most dreaded topics of the entire JEE syllabus and we will be doing the portion where students are most afraid of. You must have seen a lot of problems where you are given an equation and you want to solve, you want to find the number of solutions of that particular equation. So today's discussion will be around that topic and we will be taking problems one level up every time. So you will be learning every new concept one by one. So let's stay tuned and try to understand all the problems one by one. And this is JEE Live English and that is where we are giving you a lot of content day by day, and we are trying to incorporate and bring in a lot of new teachers for all of you guys, so that you also get quality education not just in Hindi on Unacademy JEE channel but also in English on this channel, which is Unacademy JEE English channel. If someone is new to this channel and doesn't know my credentials, then I am Sameer Chincholikar. I have done my BTech and MTech from IIT Roorkee and I have more than 10 years of teaching experience, and we have been doing this for a lot of time. You can stay connected with us on Instagram also, which is our official Instagram page, and Unacademy JEE official, and you can also go and visit tinyurl.com/JEEmobile. These are the lectures that we have taken on Unacademy JEE channel. You can just access those lectures right from this particular page by going to tinyurl.com/JEEmobile, and you can also find the notes. Notes are all in English so that you can actually read those notes and try to understand what the topic was under discussion. If you know a little bit of Hindi, then you can actually play the lectures and see what discussions we have already done there. Alright, and you can always go for Unacademy subscription, and if you go for Unacademy subscription, you will find all the live classes. All the teachers who are taking classes on Unacademy JEE and Unacademy English are also present on Unacademy subscription platform, and that is where you will be able to solve your doubts, as well as you will get a national level test series to actually analyze how far your preparation is going, in what direction your preparation is going. So all these things are really important for any JEE aspirant, which you can find there. All right, and along with us teachers, there are plenty of teachers who are masters in their subject, and those teachers are also teaching on Unacademy platform, and that is the reason we always advise students to go for it. There the subscriptions are also very affordable. You can just download the Unacademy learning app and just see what all facilities you will get once you take subscription. All right, so the subscription can be taken by going to plus category and selecting your goal, which is IIT JEE in your case. If you take subscription, you just have to let us know that for how much duration you want to learn all these topics. All right, so there is a subscription of 1 month also, and there is a subscription of up to 24 months also, which means 2 years, right? So as you increase the number of months that you want to stay connected, your price per month will go down drastically. The 1 month subscription is for 6,000 rupees per month, but the 24 month subscription costs you around 2,000 rupees per month, and once you use a referral code, which is SAMEERLIVE, that will give you additional 10% discount, and your 2-year price will be something like this, 43,000. Now this is really affordable prices. If you try to look at the prices that students are paying in offline coaching institutes, then this is something which is very commendable. Unacademy should be appreciated for this, that quality education is being provided in online format, which is much more convenient to students, and that too at such affordable prices, right? So just go and look at all the courses that are currently running and which are going to be in the upcoming section, so that you get a fair idea of what you will get in coming months and how your studies will go once you join that platform. All right, so let us continue our discussion, and this time we want to discuss few questions where the concepts of permutation and combination are applicable, but the questions look something like this, where some equation is given to you and you need to find the number of solutions. Now in this case, there are few important terminologies that we need to understand. Number of non-negative integral solutions. This is something important that you need to focus on. Non-negative. So what do you understand by this? First of all, it should be an integer. If it is a non-negative integer, which means that I cannot take -1, -2, -3 as the part of the solution. So what I am left with is 0, 1, 2, 3, 4. So all these values starting from 0, which means that whole numbers. So all the possible values which fall under the category of whole numbers should be included in my solution. Now what the question is exactly, let us look at the question. Here we want to solve a system of equations, and the system of equations are given to you like this: x plus y plus z plus u plus t is equal to 20. This is the first system that we want to use, and the second is x plus y plus z is equal to 5. We need to use both of these equations and try to find the number of solutions. Now the second equation is very easy. Here we can see that x plus y plus z has to be equal to phi. But since x plus y plus z has to be equal to phi and we need to solve this simultaneously, so I can actually replace this entire entity with phi in the first equation. If I change that, what will I get? I will get a very simple equation. I can just take this phi on the right hand side and I will be left with just u plus t is equal to 15. So these are the actual equations that we want to solve in this particular question. Now what should be the approach? What should be the approach to actually get to this answer? Now a lot of students try to solve this using multinomial theorem, which is absolutely right. This question can be solved by using that particular approach, but we also have a bypass method. We also have a method which can actually help us avoid using multinomial theorem, which is not that brilliant of an approach if you want to solve this particular question in your competitive examination, because competitive examinations you need to solve questions very quickly. So let us look at a particular method which is called partition method, or which is called ball and stick method, which we have discussed in detail on Unacademy JEE channel. Let us try to understand what that method actually tells us. So here the first equation is very easy. Let us start with that. X plus y plus z has to be equal to phi. So here what you need to imagine is there are let us say 3 students and the names of the students are x, y and z, and we want to distribute 5 apples. We want to distribute 5 apples among 3 students. This is the practical scenario which can help you to get to the answer of this particular equation, to get to the number of solutions of this particular equation, right? We are not looking at the exact solution. We are not looking at the exact solution, which is 113. We are looking at the number of solutions which are possible for this particular equation, right? So we are focusing on how many triplets can be formed, right? So here the pictorial representation can go something like this. Since I have 5 apples with me, so let us plot those 5 apples here. So I am just plotting 5 apples, right? And if I have to divide these apples into 3 students, then all I need is placing 2 partitions here. If I place 2 partitions, what am I getting is I am getting 3 different divisions. The first division will go to x. The first division will go to x, the second division will go to y, and the third division will go to z. Isn't this easy, right? What we are doing is we are pictorially understanding what kind of solutions can be generated. But I can actually change the position of partitions now. If I change the position of partition and if I place the partition something like this, these are my 5 apples that I have placed, but now the partitions are like this. One partition is in the starting, one partition is in the end. Then in that case, how are you imagining the values of x, y and z? X is always the value of apples that you have before the first partition. So before first partition I have nothing. That's why what I get is x is equal to 0. Y is the value of number of apples that are present between the 2 partitions, and that's why in this case your value of y should be equal to 5. And pictorially what we are getting is that value of z should be equal to 0. Is this one of the possible solutions? Is this one of the solutions? 0, 5, 0. Yes, exactly. This is a possible solution because here every bit of condition is already satisfied, right? So now I am getting some understanding that how can I use this particular approach to get to the answer of how many solutions will be present for this equation x plus y plus z is equal to 5, right? So what I am thinking is, why not try to arrange? Why not just try to arrange 5 apples and 2 partitions, and let us see how many cases do we come up with. Okay, so here I have total how many objects? I have total 7 objects. 5 are my apples and 2 are my partitions. How many objects I have? I have 7 objects. So how can I arrange 7 objects? I can arrange 7 objects by 7 factorial ways. But since here 5 objects are alike, that's why I need to divide it with 5 factorial, and 2 objects are again alike. These fictitious partitions that I have used are also alike, so I will further divide this by 2 factorial. This comes out to be equal to 7c2. You can directly solve it and get the value. How much will this be? This will become 7 into 6 upon 2, which will be 7 into 3, which is 21, right? So these many solutions are present. By using this pictorial representation, I am able to get to the number of solutions of the equation x plus y plus z is equal to 5. Now this is a very brilliant approach because now the second solution becomes very, very easy for us. We need not even now plot all these apples on the board, right? What we can do, we can just imagine. If I want to do a similar thing for the second equation where u plus t is equal to 15, so in my mind I can really imagine that I have 15 apples with me and I need to distribute 15 apples among two people. So I will place all the 15 apples on a table and I will place a partition between those. Since I have to divide these into only two people, I will use only one partition. If I use only one partition, how many objects will I generate? I will have 15 apples and one partition, total 16. Right? So for second equation, this is for first equation. For second equation, I have 16 objects in all. But of these 16 objects, one is a partition and rest of the 15 are apples which are alike. So I need to divide this further with 15 factorial, and that leaves me with 16 as my answer. So there are 16 possible ways in which I can create the solution of u plus t is equal to 0. You can actually practically imagine this also, because how many solutions are there for u plus t is equal to 15? If I ask this to a student who is in class 9th maybe, so even he can answer this, because he will start taking the cases. He will say the possibility is 0 and 15. Then we will have 1 and 14, then we'll have 2 and 13. So by this method you will also count and get 16 as the answer. But now it is becoming even easier to understand how to get to 16, right? So I have the number of possibilities of getting the answers to these, but separately. What I need to do is I need to find the final answer, because here simultaneous system is given to us. So what will be our final answer? The first equation can have 21 different possibilities of xyz, and the second equation will have how many possibilities? Second equation will have possibility of 16. So my total answer should lie as in I will multiply these two values and that should be my final answer. So final answer should be 21 into 16, and what will that become? Just try to calculate it. It will be 336. Is that clear? It will be 336. Alright, so this is a very innovative way and very easy way to calculate the number of solutions of a given particular equation. But here students should realize that there are few restrictions to these methods. The first is 0 should be included as one of the solutions. 0 should be included as one of the solutions. Here, if we just don't want 0 as the answer, then we will have to neglect this particular case. We will have to include cases only like this, right? So this will become an issue if the question is not for non-negative. Non-negative is the best scenario where we want to use the partition method as discussed here, right? So let us move on to our next question and try to understand where the problem lies. So here the question goes something like this: the number of integral solutions. Here also I want integral solutions of the equation x plus y plus z is equal to 0. But here some conditions are given to me. X has to be greater than or equal to minus 5, y has to be greater than or equal to minus 5, and z has to be greater than or equal to minus 5. The pictorial representation that we just saw needs us to include solutions which are from 0 to infinity. We can go up to any higher number, but it should be greater than 0 and it should be integral solution, right? So this particular condition is not right for us. So initially what will I do? I will try to change my variable and I will change my equation which suits the partition method, right? And how can that be done? I have x as greater than or equal to minus 5. So can I replace this with some another variable? I can use a substitution x is equal to minus 5 plus a, where a is greater than or equal to 0. Just try it out. If a is greater than 0, if a is greater than or equal to 0, will that make x greater than or equal to minus 5? Yes, it will, which means that this is a very valid substitution, right? Similarly, let us try for y. If y has to be greater than or equal to minus 5, I can substitute y is equal to minus 5 plus b, in which case I will get b greater than or equal to 0. Similarly, I can substitute z, which is initially greater than or equal to minus 5, as z is equal to minus 5 plus c, and c has to be greater than or equal to 0. What is the benefit of doing this? If I make this change, then I will get an equation in a, b and c which will follow the condition of partition theorem, which will follow the condition that we use in ball and stick model, right? So you must have studied this in books either by the name of ball and stick model or a fictitious partition. Both of these are very valid name for the method that we are using here. Let us try to incorporate this in our equation. If I replace x with minus 5 plus a, minus 5 plus b, and minus 5 plus c in place of y and z, then finally what equation we will get? We will get a plus b plus c is equal to 15. A plus b plus c is equal to 15, and the variables have this condition. They should be integral and they should be greater than or equal to 0, which is exactly what we call non-negative. These actually are non-negative integral solutions, right? And now our questions become very easy. Now how will I imagine this? I will imagine it like having 15 apples with me and trying to distribute those 15 apples among 3 people. So if I have to distribute something among 3 people, how many partitions will I do? I will place 2 partitions so that I will get 3 divisions, right? So all in all, how many objects are you imagining? There are already 15 apples. You have introduced 2 partitions, so there are total 17. There are total 17 objects that we are trying to arrange. So if I arrange 17 objects, I can write it as 17 factorial. But among these 17 objects, I already know that 15 are alike, 15 apples are alike. So I will divide it by 15 factorial. And I also know that the 2 partitions that I introduced are also alike. So I will further divide it by 2 factorial. Just try to calculate this, how much this will be. 15 factorial will get cancelled out and you will be left with 17 into 16 upon 2, and this should be equal to 136. Right? So again, a very easy approach to solve this. Let us do more questions so that we get used to the method that we are using and getting to the answers. Let us look at the next question, which is this: the number of points in space whose each coordinate is a negative integer such that x plus y plus z plus 12 has to be equal to 0. Again, some kind of equation is given to us, some condition is also given to us in the question, and we will again try to change the conditions according to our suitability, so that we can use our method of fictitious partition, right? So I know my conditions. My conditions are, my variables should follow greater than or equal to 0. My variables should follow the condition greater than or equal to 0. Now how will I do that? Currently the variables are less than or equal to -1. Can you see this? Because the variables should be negative integers. 0 is not a negative integer, right? So where will I start off? I will start with -1, -2, -3. These could be the values of x, y and z. Now that is not that easy to imagine. So let us try to change this. First of all, I don't want negative integers. Let us try to first convert this expression into positive integers, right? So let us just substitute x is equal to -a, y is equal to -b, and z is equal to -c. If x has to be a negative integer, a should be greater than or equal to 1. Just try it out. B has to be greater than or equal to 1. C has to be greater than or equal to 1. Why is that? Why cannot they be directly greater than or equal to 0? Because if I use 0, then x will become 0, and 0 is not a negative integer. I want that the value of a should be such that x becomes a negative integer, right? So that is giving me an idea that a, b and c all should be greater than or equal to 1. Okay, so if I now change my equation, what will I get? My new equation will become a plus b plus c. A plus b plus c should be equal to 12. Are you guys able to imagine this? I will substitute -a here, -b here, -c here. ABC will go on that side, and I will get a plus b plus c is equal to 12. So this is the equation. But the conditions on the variable is still not right. The condition on the variable which I am trying to solve should be always greater than or equal to 0 to apply the partition method. So I will again think of some substitution. It is very easy game that we are playing, isn't it? So we will now again change. We'll change a as 1 plus t1. We'll change b as 1 plus t2, and we'll change c as 1 plus t3. So if I want a to be greater than or equal to 1, t1 has to be greater than or equal to 0, and t2 similarly has to be greater than or equal to 0, and t3 similarly has to be greater than or equal to 0. If I make the change in this given equation, what will I get? I will get a new equation in terms of t1, t2, t3. t1 plus t2 plus t3 has to be how much? Here if I get 1 plus t1, 1 plus t2, 1 plus t3. So these 1, 1, 1, 3 will go on the right hand side, and I will get equal to 9 as my equation. T1 plus t2 plus t3 has to be equal to 9. Now this is a very good equation which can be solved using the pictorial method that we have just learned, right? Which is the method of partition. How many apples I have now? In this case, I have total 9 apples. In how many people I want to distribute this? I want to distribute this among 3 people. So how many partitions do we imagine? We imagine in all 2 partitions. So how many objects we have? We have total 9 plus 2 objects. We have in all 11 objects. Alright, we are arranging 11 objects. So that's why 11 factorial. But of these 11 objects, how many objects are same? 9 apples are same. That's why we divide by 9 factorial. And 2 partitions are same. Therefore, we divide further by 2 factorial. This is how much? This will become equal to 11 into 10 upon 2, which is equal to 55. Again, a simple solution. But we need to imagine all the substitutions that will actually create an equation in the variables that follow the required condition. Satisfying the required condition is very important to apply this method, right? All right, so let us further make some changes here. Let us look at one more question. Here again we will have to think further. If A, B and C are 3 natural numbers in AP, A, B, C are 3 natural numbers in AP such that A plus B plus C is equal to 21, then the possible number of values of A, B and C are, how many possible values of A, B, C can we imagine? How many combinations can we imagine? Right? How many triplets can we imagine? This should be the right statement for this question. So since we already know arithmetic progression very well, can I say that if my middle number is equal to B, or can I write the standard expression of AP? If ABC are in AP, if ABC are in AP, I know a very simple condition that 2B should be equal to A plus C. In the current equation, can you see that we have A plus C in the expression? So if I replace A plus C as 2B, what will I get? Since A plus B plus C is equal to 21, and I replace A plus C with 2B, I will get 3B is equal to 21, which means that B has to be equal to 7. I cannot change the value of B. B has to be equal to 7 if these values are in AP and they satisfy A plus B plus C is equal to 21. B has to be equal to 7. Right? Now if B has to be equal to 7, what can vary? Only the values of A and C can vary. If only values of A and C can vary, and the sum has to be equal to how much? Sum has to be equal to 14, isn't it? If I use value of B equal to 7 and I take it on the right hand side, I will be left with a very simple equation. A plus C has to be equal to 14. But is this the right equation where we can apply the method of partition? No, this is not the right equation, because the condition of ABC is that these should be natural numbers. And what is the meaning of natural numbers? That A is greater than or equal to 1 and C is also greater than or equal to 1. But to apply the method of partition, what we are looking for is these kind of restrictions on our variables. Greater than or equal to 0 is the correct restriction that you are looking out for. Right? So again, we are in need of some substitution, but now I guess you are catching up. The substitution that we need is A should be equal to 1 plus T1 and B should be equal to 1 plus T2. B should be equal to 1 plus T2. Alright, so if I replace these values, what my new equation will give me? My new equation will be T1 plus T2 is equal to 12. New equation will be T1 plus T2 equal to 12, and now I can use the partition method. So how many apples I have? I have in all 12 apples. I need to distribute them into 2 people. So how many partitions I will need? 1 less than the number of people, which means that I will need only 1 partition. So all in all, how many objects I have? I have total 13 objects. So that means I can arrange those 13 objects by 13 factorial ways. But of these 13 objects, since 12 objects are similar, I will have to divide it by 12 factorial, and that will leave me with the correct answer, which is 13. This equation can have 13 different solutions, and 13 different solutions will satisfy the conditions given in the question. The numbers will be in AP and they will be natural numbers, right? We have just made the corrections so that we can get to the equation where partition method is applicable, right? I hope you are getting a hang of it. You can make a lot of such equations, and you can even make inequalities that can be solved using this method, and all these questions can interestingly be solved by multinomial theorem also. But what you see here is way easier to understand, way easier to visualize, and even to calculate, right? So we will avoid multinomial theorem as much as possible. As much as possible, we will try to avoid multinomial theorem. Getting it? So let us try one more question here. Next question is the number of non-negative. Alright, so non-negative, this is a favorable situation because partition method is applicable on non-negative integral solutions. So we might not need a lot of substitutions in this question. The number of non-negative integral solutions of x1 plus x2 plus x3 plus 4x4 is equal to 20 is. Now here the issue is the last variable also has a coefficient. The last variable also has a coefficient, and if some of you are interested, you can actually look into books and try to find the solution of this question, and you will find a solution which will be in terms of multinomial theorem. Multinomial theorem will give you answer to this question, but we still want to find a way to get around the theorem and use our partition method, because that is so much easier to understand and so much easier to apply. All right, so what I suggest here is let us try to take different possible values of x4. Let us try to take different possible values of x4, right? So since x4 has to be non-negative integer, what all possible values of x4 can you imagine? So instead of going about and trying to understand the solution in terms of multinomial theorem, let us try and make a table where all possible values can be written down. Let us try to make multiple cases out here. x4 can be equal to 0, yes, because 0 is non-negative. x4 can be equal to 0. Then x4 may be equal to 1 also. x4 can be equal to 2 also. And if you just analyze this, x4 can in the end be equal to 5, not more than that. Because if x4 is equal to 5, 20 will cancel out and we'll get x1 plus x2 plus x3 is equal to 0, right? So these are the possible values that you will get here. Clear? Okay, so if x4 is already equal to 0, you know this case that x4 is equal to 0, your new equation will be what? Your new equation will be, in that equation, if x4 is equal to 0, we will get x1 plus x2 plus x3 is equal to 20. This is the new equation that we want to solve in the first case. x1 plus x2 plus x3 is equal to 20. So that again becomes a very easy problem to solve, isn't it? We have solved so many problems now, and I guess now you can orally get to the answer of this. And how will you do that? There are 20 apples. We need to distribute into 3 people, which means that we need 2 partitions. So all in all we have 22 objects. 22 objects, 2 partitions, 22 C2. Okay, 22 C2. The actual expression should be 22 factorial upon 20 factorial and upon 2 factorial, right? So that will that can be compressed as 22 C2. What happens if I take x4 is equal to 1? If x4 is equal to 1, I will get a new equation which is x1 plus x2 plus x3 is equal to 16, isn't it? Because if I use x4 is equal to 1, the entire expression will become equal to 4, and on the right it will give us 16. So now we have 16 apples and 3 people, so that the final answer will become 18 C2, right? So are you able to understand the pattern that we are going to create? x1, x2, x3. Next, if x4 is equal to 2, we will subtract 8 and we will get 12 on the RHS, and that's why we will have 12 oranges, 12 apples and 2 partitions, which will give us 14 C2. 14 C2, right? And in the end, if I take 5, because we are now able to understand the pattern, no need of writing everything in between, x1 plus x2 plus x3. Alright, so what we have here is x1 plus x2 plus x3, and that should be equal to how much? If x4 is equal to 5, this has to be equal to 0. So I don't have any apples. I have to distribute 0 apples among 3 people. How many ways are there? There is one way, and that can be written as 2C2. 2C2, right? So the pattern that we are following here is we are reducing our upper index by 4. We are reducing our upper index by 4. Alright, and is this a difficult expression to calculate? No, it is not at all difficult, right? 22 C2, 22 into 21 upon 2, 11 into 21. You can actually calculate this. You can actually calculate all the 6 values here, and you can just add those values, because either x4 can be this or that. So whenever you use the word or, we add the cases. If we are using and, which we did in the first question of the day, there we used and because there were simultaneous equations, right? So there we multiplied our end results. Here we will be adding our end results, and when you do that, you will get 536 as the final result. Just try to do this. This is an interesting problem to end our class. I hope you got a hang of the partition method, which is very important for your JEE syllabus, and it is really interesting to learn such methods. These actually give us the answers really quickly. If you want to further take the discussions with us, then we all are present on Unacademy Plus. Unacademy Plus subscriptions are now available from 1 month up to 24 months. You can decide how much time remains with you to master the concepts of JEE, and you can always use SAMEERLIVE as your code for 10% discount, and we would be very happy to help you further in your studies and improving your probability of getting selected in JEE and other prestigious colleges, right? So so you can definitely follow us on Unacademy JEE English. We'll be coming here quite often and delivering all such interesting lectures to you, so that you also face if you are facing some difficulty, that can be rectified right here. You should subscribe to this channel, because this will be loaded with a lot of content in coming days, and also press the bell icon so that you don't miss out on any of the lectures that we are doing here. And also, if you like something, do like it, and do press the like button and share it among friends, so that more students can get connected and get benefit of the hard work that we are doing here. All right, so that's it for the day. Take care. Bye bye.